Welcome. So, you've probably been there. You're trying to run a regression, and you hit this wall because you want to include categorical data, stuff like race or sex. It is a super common problem, but guess what? There's a really elegant solution. This explainer is all about mastering that solution, dummy variables.
Okay, here's how we're going to tackle this. We'll start with the why, like what's the actual problem we're solving? Then we'll get into the what, as in what exactly is a dummy variable? And finally, we'll cover the how to create them, how to read the results, and how to use all of it to tell a really compelling story with your research.
All right, let's dive into section 1. It's what I call the true zero problem. This is all about why some of your data just completely breaks the regression model.
I mean, it seems like it should be easy, right? You just pop the variable in and let the model do its thing. But regression, it turns out, is a little picky. It has a very strict rule about the kind of numbers it can handle, and our categorical data just doesn't play by those rules. Just take a look at this regression output. I mean, the model is trying, but what it spits out is total nonsense. It's telling us that for every 1 unit increase in race, the age at first birth goes up by 0.1 years. Think about that. What on earth is a 1 unit increase in race? It's just gibberish, and that's because the numbers we assign to the categories are totally arbitrary.
So here's the real issue, the heart of the problem. Regression absolutely needs a meaningful true zero to do its calculations. Things like age or income, they have one. 0 years old, $0, that makes sense. But for nominal variables like race, where the numbers are just labels, 1 for white, 2 for black, whatever, there is no zero. Those numbers are just placeholders, and the model gets totally confused.
Okay, on to section 2, the dummy variable switch. This is where we get to that really elegant solution to our true zero problem. So, how do we fix this? Well, we bring in this incredibly useful tool called a dummy variable. You can think of it as a special kind of variable that we create specifically to translate our categories into a language that regression can finally understand. And honestly, the best way to think about a dummy variable is as a simple on-off switch. That's it. 1 means the characteristic is there, it's on. 0 means the characteristic is absent, it's off. And that simple little binary, that 0, gives us the meaningful true zero we were missing. And here's how that magic trick works. We take our original variable, say race, and we split it up. Every single category gets its very own dummy variable. So for the white dummy variable, if a person in our data is white, they get a 1. If they're not white, they get a 0. And just like that, 0 suddenly has a very clear meaning, not white.
Now we're at section 3, how to create dummies. Let's get practical and walk through how to actually make these things.
Okay, there are basically 4 key steps. 1. Always clean up your variable first. 2. Make a new dummy for every single category. 3, and this is super important, it's a strategic choice. You pick your reference group. This is the baseline, the group you want to compare everyone else to. And 4, when you run the regression, you put in all your new dummy variables except for that one reference group.
So how do you actually do this in your stats program? Well, the source material shows 2 great ways. You can write out the syntax code, which is awesome because it gives you total control and you have a perfect record of what you did. Or, if you have a bunch of variables that are all measured the same way, you can just use the recode into different variables menu. It's a really quick and efficient way to do it. Now listen up, because this next bit of advice, a direct quote from the source, might be the single most important tip in this entire process. Seriously, this is gold. You have to, and I mean you have to, always double-check your work by running frequency tables. You need to make absolutely sure that the number of 1s in your brand new dummy variable perfectly matches the number of people in that category from your original variable. Trust me, this one simple check will save you from a world of pain and confusion down the line. All right, section 4, interpreting the results. This is where we learn how to translate all that computer output into a story that actually makes sense. So here it is, our new regression output. Now look closely. You see black_D and Hispanic_D in the model, right? But white_D, it's missing. That's on purpose. By leaving it out, we've made it our reference group. It's the silent baseline that everything else is now being measured against. The whole story is now told in relation to that group. Okay, so how do we read these numbers? Let's look at the coefficient for black_D. It's -2.36. What that means is, after controlling for everything else in our model, black respondents are predicted to have their first child 2.36 years earlier than our reference group, white respondents. See, the entire story is in that comparison.
Now, if you're kind of scratching your head, wondering how the math works, how the model just knows who the reference group is, don't worry. The author of the source material totally gets it. They admit they were baffled at first too. So let's make this crystal clear.
And here it is. This is the aha moment where it all clicks into place. Look at the simple averages on the left. Now look at our regression output. The constant, 25.54, is the exact average for our reference group. And the coefficient for black D, negative 2.99, is just the difference between the white average and the black average. It's not magic, it's just really elegant math. The model is literally just calculating the differences from whatever baseline you chose.
And that brings us to our final section, telling your research story. This is where we bring everything together.
So when you're writing up your paper or your report and you build your results table, don't make your readers guess what you did. As this example shows, you should always clearly label which group was your reference group. It's a simple little note that makes your whole analysis transparent and super easy for others to follow.
And this is really why this all matters so much. When you use dummy variables, you can go way beyond just simple statements. You can make these precise, controlled comparisons. We can say things like, education is a key predictor. We can actually put a number on the difference between groups, all while holding other things constant. We can even see how our model works differently for men and women. We get to tell a much richer, more nuanced story with our data.
And that leads us to one final thought. Remember how in our main model, the difference between Hispanic and white respondents wasn't significant? Well, why would that be? The source author has a theory. Maybe the category Hispanic is just too broad. Maybe it's lumping together foreign-born and US-born people who have really different life experiences. And you know what? That's what great analysis does. It doesn't just give you answers, it helps you ask smarter, more interesting questions for your next project.